Good morning, sir. This is E. Dinesh Kumar. And today's and today my presentation is about fuzzy C means. First we will know. First we will know what is meant by fuzzy C means. Before that we will go into the data warehousing and the data mining. In the realm of the data management and the customer analysis, data warehousing and the data mining are the foundational processes that enable organizations to store, manage, and derive insights from the massive data sets. The fuzzy cement FCM algorithm and a sophisticated clustering technique enhances this process by addressing complex overlapping data patterns. This guide explains each concept and also illustrates how FCM integrates with data warehousing and the data mining using practical examples. First, we will go into the data warehousing, the uh, uh, foundation. Data warehousing is the process of collecting and storing data from the diverse sources such as transactional systems, customer records, or logs into a centralized repository known as the data warehouse. Unlike operational databases focused on the real-time transactions, data warehouses are designed for the analytics tasks like reporting, trend analysis, and the strategic decision making. Core characteristics. Centralized storage integrates data from the multiple sources in a consistent format, and the structure will be often employs dimensional models with the facts and dimensionals like time or location. Purposes will be facilitates historical analysis and the business intelligence. Example. A retail chain might store years of sale customers and the inventory data in a warehouse to penalize seasonal trends or optimize stock levels. Uh, this is about the data warehousing. And now we will go into the data mining. Extracting insights. Data mining involves uncovering hidden patterns, correlations, or the anomalies within large data sets typically sourced from a data warehouse. It leverages techniques like classification, clustering, and also association to transfer raw data into actionable knowledge. Key methods. Key methods will be classification, essence labels, clustering, group similar items, segmentation, customers, association, identify relationships. Example, items frequently bought together. The example will be mining a retail warehouse might reveal that the customers buying diapers often purchase baby formula. It means the customers will buy. mm, It means the customers, the customers in the mining will be it's a retail warehouse buying diapers often purchase baby formula, guiding product placement strategies. Formula. And now we will go into the fuzzy C means. FCM. Fuzzy C means is a clustering algorithm used in the data mining that allows data points to belong to multiple clusters with varying membership grades values between 0 and 1. Unlike rigid methods like k-means, FCM accommodates ambiguity and the overlap, making it ideal for the real-world datasets. This is about the fuzzy means in the introduction. Now we will go into the mechanism. In this mechanism, assigns each data point a membership value for the memory cluster. Minimizes a objective function based on distance to cluster centers. Adjust by a fuzziness parameter mm, typically m is equals to 2, m is equals to 2, m is equals to 2. Iterates until cluster centers and the membership stabilizes. User case. The customer segmentation a shopper might be a 70% budget buyer and a 30% luxury seeker, reflecting mixed. And now we will go into the numerical example. Let's apply FCM to a simple data set. X is equals to 1, 2, 4, aiming for the two clusters. C is equals to 2 with M is equals to 2. Initial memberships randomly assigned. U is equals to 0.9, 0.1, 0.5, 0.5, 0.1, and 0.9. Here, uh, x is equals to 1, 1 leans towards cluster 1, x is equals to 2 is split, and x is equals to 3 uh, favors cluster 2. Calculate cluster centers. Formula. Vj is equals to sigma of n I is equals to 1 u m I j into xi by sigma n I is equals to 1 u m I j. Cluster 1 will be b1 is equals to, then there will be, you should make the matrix values whole square. Then we will do 0.9 square minus 1 plus 0.5 square into 2 plus 0.1 square into 4 by 0.9 square plus 0.5 square plus 0.1 square. That is equals to 1.26. Now cluster 2. Cluster 2 will be V2 is equals to 0.5 whole square, 0.5 square into 2 plus 0.9 square into 4 by 0.1 square plus 0.5 square plus 0.9 square. It will be 3.50. Updates membership formula Uij is equals to 1 by sigma C k equals to 1 by dij by dik 2 by m minus 1 for x2 is equals to 2. Distances d21 is equals to d2 minus 1.26 is equals to 0.74. D22 will be 2 minus 3.50 is equals to 1.50. Q21 will be 0.804. U22 will be 0.196. After repetition, X2 has 80% membership in the cluster 1 and 20% cluster in the cluster 2, reflecting its intermediate position. Graphical, now we'll go into the graphical illustration of the FCM. Consider a 2D dataset with the overlapping clusters. Like example will be cluster 1, centered to 2, comma 2, 2, comma 2, 2, comma 2, points like 1, comma 1, 1, comma 1, 1, comma 1. Cluster 2 will be centered 5, comma 5, 5, comma 5, 5, comma 5. Points like 5, comma 5, 5, comma 5, 5, comma 5. Overlap. Point 3, comma 3, 3, comma 3, 3, comma 3 between them. FCM output will be 1, comma 1, 1, comma 1, 1, comma 1. Then there will be 95% cluster 1 and the cluster 2 will be 95% means remaining means 5%. Then next one will be 5, comma 5, 5, comma 5, 5, comma 5. 95% cluster 2, 5% cluster 1. Now the another output will be 3, comma 3, 3, comma 3, 3, comma 3, 60% cluster 1, 40% cluster 2. Visualization will be plot points on 2D grid. Use red for cluster 1, blue for cluster 2, and purple shades for overlap. Example 3, comma 3, 3, comma 3, 3, comma 3. FCM shows a smooth gradient unlike K-means sharp boundaries. Code. Code will be input numpy as MP, def e- equivalent distance x1, x2, return MP into some sqrt, MP into some x1 minus x2 into 2, def for this means data, common number clusters, m is equals to 2, max iterations 100, error threshold is equals to 0.001. The parameters will be data, numpy, array of shape, n samples, and features containing the data sets. Now, clusters, number of clusters, fuzzy parameter, max iterations, maximum number of iterations, error threshold, convergence threshold, returns, centers, final cluster centers, membership, final membership matrix. All this will be written on the code. Now, you will see the output of the code. If we run this code, then the output will be like this. Fuzzy C means first in 2D. This will be the output. If you go back, this will be the output. Now we will go into the FCM and the data mining, which will be the which will be what will be the advantage of it. You will see them. FCM enhances data mining by capturing overlap, ideal for the data sets with the ambiguous groupings. Applications will be customer segmentation, identifies mixed customer profiles, image processing, segments region with fuzzy edges, example tumors in the medical scans, or the pouted detection, flag points with low membership across clusters. Example, mining a warehouse, FCM might group customers into overlapping segments, embedding advanced marketing strategies. Now we will see in the data warehousing. FCM supports data warehousing by data organization, tags data with the fuzzy categories. Example, a product has 80% electronics, 20% accessories. Query efficiency, pre-clusters data for the faster retrieval. Mining prep, structures data for the downstream analysis. Example, in a warehouse, FCM could categorize inventory, speeding up queries like list of electronics while retaining overlap insights. Practical integration example will be if imagine a retail data warehouse like with sales, customer, product data. Warehousing stores and drop off organized data by time, location, and category. Mining with FCM. Customers, clusters customers. Example, uh, if a buyer with 0.7 budget and the zero point 0.3 premium membership, it will be mining with the FCM. Your result. Fuzzy clusters enrich the warehouse, enabling precise marketing queries with the fast access. Conclusion. Conclusion will be data warehousing provides a robust platform for the data storage, the retrieval, uh, while the data mining extracts valuable insights. As you see, means FCM enhances both by offering a flexible clustering approach that handles overlap, as shown through numerical and the graphical examples. Together, they can empower organizations to manage data effectively and make informed decisions. This is both the CM and this is all about the fuzzy C means and also the fuzzy C means in the data warehousing and the data mining. Thank you.